I want you to imagine getting in your car and driving. Not to the store, not across the country, just driving. Straight. No stops. No sleep. At a steady 60 miles per hour. How long do you think you'd have to drive to reach the nearest black hole? Take a guess. A year? 10 years? 100? Try this. If you started driving the moment the last dinosaurs died, roughly 66 million years ago, you would still be driving right now. You'd have covered about 34 trillion miles, and you would still need to keep driving for another 23 million years before you pulled into the parking lot of the nearest confirmed black hole. That's not a metaphor. That's math. The nearest black hole we know of sits roughly 1,560 light years from Earth. 1,560. That number looks small on paper. It fits in a tweet. But light, the fastest thing in the universe, the cosmic speed limit that breaks every rule we know, takes 1,560 years just to make the trip one way. If you pointed the world's most powerful flashlight at it right now, the beam wouldn't arrive until the year 3586. And here's the hook that should make your stomach drop. That's the nearest one, the one we actually found, the one we can point to. But black holes are invisible by design. They don't reflect light, they don't glow. They announce themselves only by what they destroy or what they bend, which means the real nearest black hole could be far closer. We just don't know it yet. Before we go any further, we need to kill a misconception. Because if you're like most people, you hear 1,560 light years, and your brain files it under big number and moves on. That's a survival mechanism. Your mind protects you from scale that would otherwise paralyze you. So let's make it hurt. A single light year is about 5.88 trillion miles. That's a 5 followed by 12 zeros. Multiply that by 1,560. You're looking at roughly 9,200,000,000,000 miles. That's 9.2 quadrillion miles. If you printed that number on a standard piece of paper in 12-point font, the paper would need to stretch from New York to London and back 3 times just to hold the zeros. But numbers that big are still abstract. So let's shrink the universe down. Imagine Earth is a grain of sand sitting on your kitchen table. The moon is another grain of sand just 3 inches away. The sun? A marble about 26 feet down the hallway. Mars? A pebble in the next room. Neptune? A frozen dust mote 3 blocks away. Now at this scale, where's the nearest black hole? It's in another city. Not the next town over. Not across the county. A 3-hour drive away, in a direction you've never been, sitting in a dark apartment you'll never visit, silently eating a star we've only recently learned to name. That's how far 1,560 light years really is. It's not space is big. It's that space is so big the concept of near itself becomes meaningless. The nearest black hole is simultaneously our closest cosmic predator, and so incomprehensibly distant that humanity will likely never send a probe there, let alone a person. And yet, compared to the rest of the galaxy, it's practically in our backyard. So what is this thing? What's the name of our nearest invisible neighbor? Astronomers call it Gaia BH1. And its discovery story sounds less like science and more like a cosmic detective novel. In 2022, researchers were sifting through data from the Gaia Space Observatory, a European satellite mapping the positions and motions of nearly 2 billion stars. Most of this data is automated. Algorithms flag stars that wobble. A wobble usually means one of 2 things. The star is pulsing or it's being pulled by something massive orbiting it. Gaia BH1's companion star, a sun-like G-type star very similar to our own sun, was wobbling violently. Every 7 months, it jerked in its orbit as if yanked by an invisible leash. The math was undeniable. Something 10 times the mass of our sun was locked in a gravitational dance with this star. But when astronomers pointed every telescope they had at the location, they saw nothing. No glow, no reflection, no companion star, just empty blackness and a star being swung around by a ghost. That ghost is a black hole, roughly 9.6 times the mass of our sun, compressed into a sphere roughly 35 miles across. Think about that. Our sun is 864,000 miles wide. This thing is 10 times heavier and fits inside the distance of a morning commute, and it's only 1,560 light years away. To put that in terrifying perspective, when the light we're seeing from Gaia BH1 left its location, the Western Roman Empire still existed. Attila the Hun hadn't been born yet. The starlight we use to study this black hole began its journey while humans were still debating whether the Earth was round. That's how long 1,560 years is. And that's the closest one. But Gaia BH1 might not hold the title for long, because there's another candidate, a phantom astronomers call V723 Monocerotis, or the Unicorn. The Unicorn sits roughly 1,500 light-years away, slightly closer than Gaia BH1. It was discovered because a red giant star is being slowly drained by an invisible companion. The star is being stretched into a teardrop shape by tidal forces. Something dark and massive is pulling its atmosphere away, sucking it into an accretion disk we can barely detect. Initial calculations suggested the invisible companion was about 3 times the mass of our Sun. That puts it in the black hole category. But here's where it gets messy, and where your brain should start melting. Some astronomers think the unicorn might not be a black hole at all. It might be a neutron star, or a particularly dim white dwarf, or even a binary system where the geometry tricks us into seeing mass that isn't there. The data is ambiguous. The unicorn is either the closest black hole to Earth, or it's a completely different kind of monster we don't fully understand. And that ambiguity? That's the real terror. Because if we can't definitively identify a black hole candidate only 1,500 light-years away, if the closest possible monster in our neighborhood is still a mystery, then what else is hiding in the gaps between the stars? The Milky Way contains an estimated 100 million to 1 billion black holes. We've found a few dozen. That means we've mapped roughly 0.0001% of the black holes in our galaxy. The rest are out there, silent, invisible, drifting through the dark like sharks below a boat. And one of them could be passing through our stellar neighborhood right now, completely undetected, completely silent, completely lethal if you got too close. Now we need to talk about the black holes that don't have companion stars. The ones that don't conveniently announce themselves by making another star wobble. The ones that are truly invisible. These are rogue black holes. And they are the most terrifying concept in astrophysics. When a massive star dies in a supernova, the explosion isn't always symmetrical. Sometimes the blast kicks the newborn black hole in one direction like a cannonball. These black holes can be ejected from their home star systems at speeds of hundreds of kilometers per second. They don't orbit neatly, they wander. Astronomers believe thousands, possibly millions, of these rogue black holes are cruising through the Milky Way right now. No companion star, no accretion disk, no radio emissions. Just a sphere of pure gravity, 10 to 30 miles across, moving through interstellar space at speeds that would cross the continental United States in under a minute. If one of these rogues passed within a light year of our solar system, we probably wouldn't know until it started bending the orbits of outer comets. If it passed through the Oort cloud, the shell of icy debris surrounding our solar system, it would send a rain of comets hurtling toward the inner planets, toward Earth. And the truly mind-melting part, the distance to the nearest black hole might not be 1,560 light-years. It might not be 1,500 light-years. It might be 1 light-year. Or less. We have no way of knowing. Our detection methods require a black hole to interact with something luminous. A rogue black hole in the dark is functionally invisible until it's close enough to bend starlight around it like a lens. So when you ask, how far is the nearest black hole? The honest scientific answer is, we don't know. Gaia BH1 is just the nearest one we've found. The real nearest one could be halfway between here and Alpha Centauri, and we wouldn't see it coming. But let's step back from the terror for a moment and talk about a different kind of proximity. Because there's a black hole much, much closer than 1,560 light-years. It's 26,000 light-years away. I know, that sounds farther. But here's the twist. You're orbiting it right now. Sagittarius A star is the supermassive black hole at the center of the Milky Way. 4 million times the mass of our Sun. Its event horizon is roughly the size of Mercury's orbit, and every star in the galaxy, including our Sun, is locked in a gravitational waltz around it. Right now, as you watch this video, you are traveling at roughly 828,000 kilometers per hour around Sagittarius A star. That's 230 kilometers per second. You're moving so fast that in the time it takes you to blink, you've traveled over 100 kilometers along your orbital path around a black hole. The distance to Sagittarius A star is 26,000 light years. But because it anchors the entire galaxy, its gravitational influence technically extends infinitely, just like yours does. Every atom in your body exerts a gravitational pull on Sagittarius A star, and vice versa. The force is unimaginably tiny, but it is not zero, which means, in a very real, very literal sense, you are touching a black hole right now. The distance between you and the nearest supermassive black hole is bridged by gravity itself. You are connected to it by the fundamental fabric of spacetime. So is the nearest black hole 26,000 light years away? Or is it zero distance away because gravity binds you to it across the cosmos? That's the kind of question that melts your mind. Let's ground this again, because I promised you the distance would melt your mind, and we're not there yet. Imagine you could fold space. Imagine you could step into a wormhole and instantly travel 1,560 light years. What would you see when you arrived at Gaia BH1? You wouldn't see a hole. You wouldn't see a tunnel. You wouldn't see the Hollywood funnel of doom. You would see nothing. A circle of perfect blackness about 35 miles across, surrounded by a single star being slowly tortured. If you were close enough, say a few million miles away, you might see gravitational lensing. The background stars behind the black hole would bend and distort around it like light through a wine glass. But the black hole itself? It's just absence. It's the ultimate negative space, a region where distance itself ends. Because inside the event horizon, the concept of how far stops working. Space and time switch places. Moving away from the singularity becomes as impossible as moving backward in time. So the nearest black hole isn't just 1,560 light years away in the normal sense. It's a place where the question, how far, becomes physically meaningless. It's a location where distance dies. Let me give you one more comparison to drive this home. If the Earth were the size of a pea, the moon would be a grain of sand held 7 inches away. The sun would be a basketball 163 feet down the road. Neptune would be a pinhead a mile away. At this scale, Gaia BH1, the nearest black hole, is in another country. But here's the kicker. At this same scale, the observable universe is 37 million miles across, which means, in cosmic terms, a black hole just 1,560 light years away is like finding a spider in your bed. It's not in the house, it's not in the room, it's under your sheets. That's how terrifyingly close it is. Now, let's play a thought experiment, because this is where the documentary gets personal. What if Gaia BH1 weren't 1,560 light years away? What if, through some impossible cosmic shuffle, it appeared just 1 light year from Earth? What would that look like? First, the sky wouldn't change much. A black hole 1 light year away is still invisible to the naked eye. You wouldn't see it unless you knew exactly where to look and had powerful telescopes watching for gravitational lensing. But the solar system would feel it. Over thousands of years, its gravity would tug at the Oort cloud, sending comets spiraling inward. Some of those comets would eventually cross Earth's orbit. The rate of major impacts would increase. Not tomorrow, not next century. But over geological time, a nearby black hole is like a cosmic billiards cue, slowly rearranging the furniture of the solar system. What if it were closer? Say the distance of Neptune, about 4.5 billion kilometers? At that distance, Gaia BH1 would appear as a perfectly circular patch of absolute darkness against the stars, about the size of a grain of sand held at arm's length. Its gravity would begin to compete with the sun's. The outer planets' orbits would destabilize. Jupiter might shift. Earth's orbit might elongate. Seasons would become extreme. Ice ages and heat waves would alternate unpredictably. What if it replaced the sun? If you swapped our sun with a 10 solar mass black hole, Earth wouldn't get sucked in. Not immediately. We'd continue orbiting it at the same distance. But without sunlight, the planet would freeze within weeks. The atmosphere would snow out, the oceans would turn to ice, life would retreat to geothermal vents or die. The black hole itself would be invisible, a 35-mile wide sphere of nothing where the sun used to be. You could look directly at it, and you'd see only the stars it bent around its edges. The ultimate eclipse. Permanent night. This is the paradox of black holes. They are the most destructive objects in the universe, but they don't suck the way movies pretend. They orbit, they warp, they wait. The danger isn't being pulled in from a distance. The danger is getting close enough that escape becomes mathematically impossible. And at 1,560 light-years, Gaia BH1 is currently no threat. But the universe moves, stars drift, orbits precess. In 1 billion years, who knows where that rogue cannonball will be? Now I need to tell you something that will break your understanding of distance entirely. Because black holes don't just bend space, they break the concept of how far at a fundamental level. Imagine you're an astronaut. You decide to visit Gaia BH1. You build a ship that can travel at 99% the speed of light. Impossible with current technology, but let's pretend. From Earth's perspective, your journey would take roughly 1,575 years. You'd arrive in the year 3601. Everyone you know would be dust. Civilizations would rise and fall. But from your perspective, inside the ship, time dilation would kick in. At 99% light speed, your clock would slow down by a factor of 7. Your journey would feel like only 225 years. You'd still die of old long before arrival, but the point stands. The distance to the black hole depends on how fast you're moving. Now let's go further. Let's say you actually reach Gaia BH1. You park your ship a safe distance away, say, a few million miles. You decide to send a probe toward the event horizon to measure it. From your perspective, sitting in the ship, the probe will appear to slow down as it approaches the black hole. It will never seem to cross the event horizon. It will redshift into infrared, then radio, then vanish from view. Frozen at the edge forever. But from the probe's perspective, it crosses the event horizon in finite time. It passes the point of no return. It plunges toward the singularity. The distance from the horizon to the center might be 10 miles. But because space is so warped, that 10 miles might as well be infinite. So tell me, how far is the nearest black hole? Is it 1,560 light years? Is it 225 years? Is it the distance from the event horizon to the singularity, a distance that simultaneously takes forever and no time at all, depending on where you stand? Black holes don't just destroy matter, they destroy the concept of measurement itself. They are cosmic interrogation rooms where the witness, space-time, gives contradictory testimony. And that's why this question melts your mind. Because the answer isn't a number. The answer is that numbers stop working when you get close enough. Let's return to the Milky Way and talk about probability. Because this is the part that should keep you awake. Astronomers estimate that a new black hole forms in our galaxy roughly once every century. Supernovae collapse. Massive stars die. The corpses accumulate. Over the 13.6 billion year lifespan of the Milky Way, that's potentially hundreds of millions of black holes. Most of them are stellar mass, 5 to 30 solar masses, 20 to 60 miles across. Invisible, unless they have a companion star. Untraceable if they're rogue. Now consider this, the Milky Way is about 100,000 light-years across. If black holes are distributed roughly evenly, and there's no reason they wouldn't be, then statistically there should be at least a few hundred black holes within 1,000 light-years of Earth, maybe thousands within 5,000 light-years. We've found 2, Gaia BH1 and the Unicorn. That means our detection rate is laughably incomplete. We're like a person standing in a dark forest with a flashlight claiming there are no bears because they can only see the trees in front of them. The bears are there, they're just not illuminated. And here's the final hook. Black holes can move, fast. When 2 black holes merge, they emit gravitational waves. These waves carry momentum. The merged black hole can recoil at speeds up to 5,000 kilometers per second, fast enough to escape the galaxy entirely. But even without mergers, supernova kicks can send black holes careening through the galaxy at hundreds of kilometers per second. A black hole born 50,000 light years away could, over millions of years, drift into our neighborhood. It could pass within a few light years of Earth, and we'd only know if we happened to be looking at exactly the right patch of sky at exactly the right moment. So the distance to the nearest black hole isn't static. It's a lottery, a cosmic shell game. The black hole that's 1,560 light years away today might have been 3,000 light years away a million years ago. And a rogue we haven't detected might be closing the gap right now, silent and invisible, on a trajectory that won't bring it near us for another 10 million years. Or another 10 years. We simply don't know. Let's bring this home, because you're not watching this video to become an astrophysicist. You're watching because some part of you needs to know where the monsters live. The nearest black hole is 1,560 light years away. That's safe. That's comforting. You could live 10,000 lifetimes and never feel its influence. But the question isn't really about Gaia BH1, it's about what that distance represents. It's about the gap between what we know and what's out there, between our maps and the territory, between our confidence and the cosmic dark. We are a species that has only known about black holes for a century. Einstein predicted them in 1916. We didn't find the first one until 1971. We didn't image one until 2019. Our understanding is younger than the airplane, and yet we're trying to map objects that are literally invisible, millions of years old, and moving through a galaxy we barely comprehend. The distance to the nearest black hole, 1,560 light years, isn't just a measurement. It's a reminder of our cosmic infancy. It's a measure of how blind we still are, how new we are to this game. Think about it. In 1900, the nearest black hole was nowhere, because we didn't believe they existed. In 1970, the nearest black hole was maybe Cygnus X1, at 6,000 light years. In 2022, it became Gaia BH1 at 1,560 light years. In 2025, the unicorn might take the title at 1,500. The distance is shrinking, not because the black holes are moving closer, but because our ability to see them is improving. And if history is any guide, the more we look, the closer the nearest one will get. Maybe in 2030, we'll find a black hole 800 light years away. Maybe in 2040, one at 400 light years. Maybe in your lifetime, we'll discover a rogue black hole in the Oort cloud. Still harmless, still distant, but close enough to make the headlines scream. The terrifying truth isn't the distance. It's that the distance is a moving target, and we don't know where it stops. Now I'm going to melt your mind one last time, because I promised I would. You asked how far the nearest black hole is. I've told you 1,560 light years. I've told you it might be closer. I've told you that in a gravitational sense, you're already touching 126,000 light years away. But here's the distance nobody talks about. The distance that renders all other distances meaningless. 0. Because every atom in your body heavier than hydrogen was forged in the core of a star. The carbon in your cells, the oxygen in your lungs, the iron in your blood, calcium, nitrogen, phosphorus. All of it was cooked in stellar furnaces billions of years ago, then scattered across space when those stars died. And the most massive stars, the ones that forged the heaviest elements, didn't die quietly. They exploded as supernova and collapsed into black holes, which means the iron carrying oxygen through your veins right now was likely born in a star that became a black hole. The calcium in your bones, the carbon in your DNA. They are the ashes of dead suns that collapsed into infinite density. So how far is the nearest black hole? It's in your blood. It's in your bones. It's in the neurons firing in your brain as you process this sentence. You are made of black hole stuff, the material that collapsed into the nearest stellar. Corpse is the same material that built your hands, your eyes, your heart. The distance between you and the nearest black hole isn't 1,560 light years. It's the distance between you and yourself, between the living and the dead, between the visible and the invisible. You are the universe's way of looking at black holes and wondering how far away they are. And in that wonder, the distance collapses entirely. As of today, this moment, the nearest confirmed black hole is Gaia BH1, 1,560 light-years away in the constellation Ophiuchus. The nearest candidate is the Unicorn, 1,500 light-years away in Monoceros. The nearest supermassive black hole is Sagittarius A star, 26,000 light-years away, and you're orbiting it at 230 kilometers per second. But tomorrow, next year, in a decade, the Gaia telescope is still scanning. The Rubin Observatory in Chile is coming online. The Nancy Grace Roman Space Telescope will launch soon. These instruments will map billions of stars with unprecedented precision. They will find wobbles we've missed. They will spot gravitational lenses we've overlooked. They will reveal black holes in our stellar backyard that we never knew existed. And every time we find a closer one, the universe will feel a little smaller, a little darker, a little more crowded with invisible mouths. The distance to the nearest black hole is not a fixed number. It's a confession of our ignorance, a measure of how much dark matter, literal and figurative, still surrounds us. So remember this number: 1,560 light-years, 9.2 quadrillion miles, 23 million years of driving. The time it takes light to travel from the fall of the Roman Empire to your screen tonight. But don't get too comfortable with it, because somewhere out there, in the gaps between the stars we've named, in the dark lanes of the Milky Way we haven't mapped, in the silent void where no telescope has looked, there might be a black hole closer than Gaia BH1, closer than the Unicorn, close enough to make us rewrite every textbook. And when we find it, the only thing more terrifying than its distance will be the realization that it was there all along, watching, waiting, 1,560 light-years away, for now.